Hello everyone, this is Simon, Solution Manager from United Energy. Today I'm very happy to share one case for you about the PV plus ESS project to present to you how is the customer requirement and how is our solution and how can we make the customer to reach their target to meet their requirement. This customer is located in Jamaica. They are an IT company. They have a lot of the power consumption. Every day they consume more than 2,200 kilowatt hour, and their energy price is very high. Per kilowatt hour can reach 34 cents. So annually they are paying 267 kilowatt-hour US dollar. So the pain point of the customer is that they want to reduce the cost of electricity. We considered their rooftop and we designed the metal roof mounting solution and make the layout. Finally, we will put 489 kilowatt peak PV panels. And for the single line diagram, the electrical design, we make several inverter of 550 kilowatt in parallel to make the whole system. In this diagram, you can see from the grid, it will go to the bus bar, and it will go to the AC combined cabinet, and the AC combined cabinet will connect with 550 kilowatt hybrid inverter. Then the output of 550 kilowatt hybrid inverter will go to the load. Each 50 kilowatt inverter, they are connecting with 184 kilowatt hour battery cluster and also around 80 or 86 kilowatt peak PV panels. This is the whole diagram, and they also will put a zero export solution to avoid the energy go up to the grid. So totally this design is around 490 kilowatt peak PV panel and 300 kilowatt inverter and 1.1 megawatt battery clusters. This is according to the estimation of the generation. Annually, this system can generate 752 megawatt hour per year. And every month their generation are very evenly, so they are not high and also very low. And also we can provide every month, every day, the daily generation. It can reach 1,700 until 2,300 something. This generation can help cover all their data center consumption. This is the work mode. In this table, you can see from the 24 hours, the load can be from 60 kilowatt until 130 kilowatt. And totally the consumption is 2,200. And the generation from the PV is 2,285 kilowatt hour. And in the daytime, the actual energy will be around 1 megawatt hour. And the battery ESS will charge during the daytime and discharge during the nighttime. So this is the table. And this is a diagram. You can see the orange curve is the PV generation. In the noon time, it's very high, and the blue one is the load curve. In the daytime, it's a little bit higher than the load in the night, and the green one is for the BESS. During the daytime, it will charge, and in the nighttime, it will discharge. So you can see all the power supply and power consumption, they are equal. So mainly in the daytime will be the model 1. The PV generation will provide the power to the load and also provide the power to charge the battery. And in the nighttime, your mainly will be the model 2. The battery will discharge to supply the power to load. Only in the early morning or in the late afternoon, the PV generation is not so much. So you have to also, the battery will discharge together with the PV generation to supply to the load. But this is only in the early morning or in the late afternoon. And when the PV generation is not so high or the consumption is too much, then we will get the power from the electrical grid to supply the power for the load. Finally, make the system or the load to be properly works. This is the BESS capacity curve. This is the SOC curve. In the noon time, it will reach 100%, and as the time is going to the late and in the evening, it will decrease. In the early morning, it will decrease around 12%. So this is the BESS SOC curve. And this is the ROI analysis. we consider we have 489 kilowatt peak PV panels and 1.1 megawatt hour battery and 753 kilowatt hour sovereign kilowatt hour per year generation, and the electricity price is $0.343 per kilowatt hour, and the investment we estimate 360 sovereign $, and the O&M cost we estimate 15 sovereign $, per year, and the construction period is 6 months, and annual generation degradation will be 1%. With this analysis, we can say that we can get the payback around 1.5 years or 2 years. We can get the payback, and the accumulated net cash flow is like this. Accumulated cash flow is like this. So we can get the payback in around 2 years, and in 10 years we can get around $2 million revenue. So it's a very worthwhile investment. So this is also why the customer they want to start their project as soon as possible. In this project, we provide PV panels. This is a very popular one. It's rectangle dual glass PV panels, N-type TOPCon. We are providing 620 watt peak, and this is very popular in the market right now. And they are very high efficiency. In the inverter part, we are providing hybrid inverter with Solis, because Solis is the top brand in this area, and their 50 kilowatt inverter is already deployed for many cases. So their product is very stable, and so we recommend this one to work for this project. And the high voltage battery rack, we are using our own brand SafeBet series, and we are using 280 ampere hour battery cells, and this is 13 models. Each model is 51.2 volt times 280 ampere hour. So each battery cluster will be 186 kilowatt hour. This is also with good top brand of the battery cells. And here is when we do the delivery, we put the battery inside the container, and we put 6 inverters in this container. We divide the 20 feet container to be 2 parts. One part is for the battery clusters, another part is for inverters. For the battery cluster, we have several air conditioner to cool down the system to make the battery cluster to work in a very good temperature. And also in the inverter part, we are using the fans to cool down the inverter. This inverter is IP65, so we put this kind of protection. It will work very properly. Right now, the project is already there, and the next step, going to the site to help them to do the online guidance and help them to do the project commissioning. So this is how our solution to meet the customer's requirement, help the customer reduce the cost of electricity. I hope this presentation will give more detailed information or more clear information for you about how we do this. And if you have similar requirement or some similar project, also you can contact with us for more detailed design and communication. And we hope we can help you in the future project. Thank you.